The point of statistics is trying to understand the world around us. So some of the things that we can look at are associations, correlation, and the ultimate thing that we're looking for is causation. We want to find out what is causing things to happen. So I need you to understand that there's a difference between correlations, associations, and causations. So causation is the highest level of connection between two things. Association is a much weaker connection between the two things, and correlation might be just an accidental connection between two things. So an association is where one variable changes along with another. So some variable which you can put on the x-axis goes up, and the variable along the y-axis can go up as well. That's positive correlation, or alternatively, as x goes up, y goes down. That's a negative correlation. You hope that one variable is responsible for causing a change in the other, but that is causation. And just because the two things are related to each other, there's an association, does not actually show that there's any causation. An example is arm and leg length, which is correlated to one another, but there's no direct causation. Your arms are not feeding to your legs, feeding back to your legs and saying, please grow longer because otherwise I'm dragging along the floor. This isn't how it works. They both grow in proportion because of the genes that fundamentally set out your body plan are connected to one another. So they share a causative genetic effect, well, genetic and environmental effect. Another bad example of thinking of correlations is rich people drive Ferraris. So if I go and buy a Ferrari, I'll become rich. This isn't the causation. The causation is if I have lots of wealth, then I can buy luxury goods. Not getting luxury goods allows me to have lots of wealth. Now, that's the point, that X might cause Y or Y might cause X when you've got an association between two things. You can't tell which is doing which. With the arms and legs, it makes no sense as to which one you put on the x-axis and which one's on the y-axis. This idea of dependent and independent variables is confusing and I don't think particularly helpful. Correlation can mean there's missing connections, and sometimes you get pure coincidences. So here is a very popular meme sort of image of the internet, which is the use of Internet Explorer versus the murder rate in the US. So as you see, the decline in use of Internet Explorer and the decline in murders in the US, and they seem to follow a perfect path, a perfect correlation between the two. So it falls slowly at first, then it's steeper, and then it shallows out again. But if you look, what you've got is murder rates of between 18,000 and 14,000, and it's a truncated scale, and you've got between 30 and 90% market share. It just happens to be a coincidence because of the way you've drawn this particular set of data. I don't think there's any particular connection between you using Internet Explorer and wanting to kill people, although there is a vague possibility, I suppose. That's why we don't use Internet Explorer anymore. This one is more interesting because it comes from the New England Journal of Medicine. So this is the relationship between chocolate consumption in kilograms per year per person and the number of Nobel laureates per 10 million population. This has a very good positive relationship. The R is 0.791. The R squared will be there's about a 64% link between chocolate consumption and Nobel laureates. So does this mean if I go out and eat 20 kilos of dairy milk, I'm going to suddenly become a Nobel laureate? Well, no. So what's in common here is disposable income. Countries with more disposable income can spend more money on research and science and more likely to get Nobel Prizes. The odd outliers within this is Sweden and possibly Switzerland, where they make a lot of chocolate, as well as having a lot of Nobel Prizes per capita, because they've got a relatively small population. You have a very important university, which is the ETH, which is created lots of Nobel Prizes. But the outlier here is Sweden, and that's above the average. They're getting more Nobel Prizes for their chocolate consumption. Now, Swedish chocolate is quite rare, so you can get it. Dime Bar, so Marabou is a Swedish chocolate manufacturer. But the reason they get a disproportionate number of Nobel Prizes is because the Nobel Institute is Swedish. So they tend to favour their own home nation. Now, here are some maps which show something a bit more interesting. So this is life expectancy in the EU in 2011. And here you can see a clear line between the red and orange groups of countries in life expectancies and those that are predominantly green. There's a bit of orange and sort of pinky buff colour in Germany as well, but most of the strong red and deeper orange colours, what does that correspond to? That corresponds to the old Warsaw Pact. So that line is the Iron Curtain that separates Western Europe from Eastern Europe. East Germany there is the part of Germany that is less green than the West Germany, although there is a bit of pinkish along the Rhine as well, which is the industrial area, and there's a surprising bits of red in Dumfries and Galloway, and I think it's Aberdeenshire in Scotland, and also in parts of Belgium. But you can very clearly see where the Iron Curtain was. Now, using exactly that same scale, those particular grades, then you can go to the US and you can see that the US is like an Iron Curtain country. Most of the states, apart from Minnesota and Hawaii, have very poor life expectancy. But you can particularly pick out a set of states that have very bad life expectancy, the same as you get in Poland, the Baltic states, Romania, Bulgaria, and all of the other countries that were behind the Iron Curtain. So that's Oklahoma, Alabama, Georgia, Arkansas, Louisiana, South Carolina, North Carolina, Kentucky, West Virginia. What do all of those states have in common? So they have in common that they were the slave states and the separatist states during the American Civil War. So the American Civil War finished in the 1860s, but you can still see the effects of segregation and slavery in the life expectancy in the US over 150 years later. If you think that I'm picking on the US just with that particular slide, let's pick some other sets of data. So there you can see Protestantism, you can see poor levels of education, you can see poverty, Baptist, diabetes, child maltreatment, teen pregnancy, venereal disease. All of them fit along those borders of which were the slave states and the states that sided with the Confederacy and those states that sided with the Northern Union. Now, one of the most important set of criteria that you need for understanding causation is called the Bradford Hill criteria. So the Bradford Hill criteria were devised to try and understand when something causes something else to happen. So they set out the basic things you need to see for causation. Cause must precede the effect. You cannot have something happening before the thing that's going to cause it occurring. You can't get lung cancer and then start smoking. The association must be plausible. So there is a plausible connection between smoking and lung cancer. There should be a consistency between studies. So when I find lots of people who've got lung cancer, they all turn out to be smokers, and the people who haven't got lung cancer, so they should turn out to be non-smokers. The association should be strong. So that means there should be a significant difference between the treated, so the smoking group, and the non-smoking group. There should be a dose-response effect, so the people who smoke more should have more lung cancer, and the people who smoke less should have less lung cancer. And removing the factor should reduce the risk. So stopping people smoking should reduce the effects within the population. Now I use smoking as an example because that's where the Bradford Hill criteria were first applied and considered, and they were applied by the Surgeon General of the US when they were summarising the connection between lung cancer and smoking.